All right, we have some awesome level 4 problems for you guys to complete. And number 1, we should automatically know that this is a proportion because we have a fraction set equal to a fraction. So we're going to use the cross products property. But here's what's interesting about this problem is when we take the numerator and multiply it by the denominator, the numerator is a binomial, the denominator is a binomial. We're doing a binomial times a binomial, which requires us to either use the distributive property or the FOIL method. I'm going to use FOIL. So I'm really doing a 4x plus a 2 times an x minus a 3. And then I'll set that equal to the numerator of my second fraction multiplied by the denominator of my first fraction, which this is a monomial times a binomial, so we don't have to FOIL that. We just use the distributive property there. All right, using the FOIL method for this one, first terms of 4x times an x is going to be a 4x squared. Outer terms of 4x times a minus 3 is a minus 12x. Inner terms, a plus 2 times an x is a plus 2x. And last terms, a 2 times a negative 3 is a minus 6. And that will equal, I'm going to distribute in my second one, I have a 4x squared plus a 6x. And then I'm going to combine like terms on the left. So now I have a 4x squared minus a 10x minus a 6 is equal to a 4x squared plus a 6x. Now, we have an x squared in our equation, and we have not learned how to solve equations with an x squared in it. And we will not learn how to solve equations with an x squared in it until second semester. So, what happens actually, since I have a 4x squared and on the left and a 4x squared on the right, if I subtract a 4x squared from both sides, guess what? Those 4x squareds disappear. And now this just becomes a standard equation that we're used to dealing with. If you end up with the x squared terms not disappearing, then you know you did something wrong because I'm not going to give you something you have not learned. So if you wind up with something you have not learned, whereas these x squareds don't disappear, then you need to go back and check your work. So from here, I'm going to solve this equation by adding 10x to both sides. And I wind up with a negative 6 is equal to a 16x. I'm now going to divide by 16 on both sides. And both a negative 6 and a 16 are divisible by 2. A negative 6 divided by a 2 is a negative 3. A 16 divided by a 2 is an 8. So I have x is equal to a negative 3/8. All right, moving on to number 2. Now, with an x minus a 3 squared, this is not just an x squared plus a 9. No, an x minus a 3 squared is the same thing as an x minus a 3 times an x minus a 3. And so we have a binomial times a binomial again. So we can either do the distributive property method or the FOIL method. I'm going to do FOIL. First terms, an x times an x is an x squared. Outer terms, an x times a minus 3 is a minus 3x. Inner terms, a minus 3 times an x is another minus 3x. Last terms, a negative 3 times a negative 3 turns into a plus 6. And then I also have that equals x squared. I'm now going to combine like terms. I can combine the negative 3x minus 3x. So I have an x squared minus a 6x plus a 9. Here is another equation where we have an x squared in it. And I'm going to remind you that we have not learned how to solve equations with an x squared in it. And we won't until second semester. So our x squares should eliminate. Let's see if they do. If I decide to subtract the x squared from both sides, an x squared minus an x squared on the left disappears, and I'm left with a 6x plus a 9. And an x squared minus an x squared disappears on the right, and I'm left with a 0. So since my x squared terms disappeared, I know I did something correctly because I have not yet taught you guys how to solve equations with x squared in them. So your x squares for right now, at least, should cancel out. We haven't learned how to do that. So now I have my variable on one side. I'm going to get all the numbers over to the right side. I'm going to subtract 9 from both sides first. I have a negative 6 is equal to, or negative 6x is equal to a negative 9. And now I'm going to divide by negative 6 on both sides. A negative 9 divided by a negative 6 is going to turn into a positive. And a 9 and a 6 are both divisible by 3. 9 divided by a 3 is a 3. 6 divided by 3 is a 2. All right, this next one is going to be tough. But what we're going to do is we're going to multiply this entire equation by a number, so that way we eliminate all of our fractions. So, looking at the denominator of each of these fractions, the common, these are all factors of 12. So let's multiply every term by 12 or 12 over 1. What this is going to do is it's going to eliminate some of my, or all of my fractions here. So a 12 over 1 times an x is just a 12x. Minus, all right, now to do a 12 over a 1 times this fraction, what we really can do is a 12 divided by a 4, which is a 3. So what I want to do is I want to multiply this numerator by 3. So a 3 times a 1 in that numerator is a 3, minus a 3 times a 3x over a 2. I just do the 3 times the 3x, so I wind up with a 9x over a 2. And that equals, now I'm going to work on this one, a 12 over a 1 times the term I circled in green. We can do a 12 divided by a 3, which is a 4. So I'm really going to just multiply this numerator by 4. So a 4 times this 2 is an 8, minus a 4 times this x over 4. I just multiply the 4 by the x, so I have a 4x over 4. And then minus, now I'm going to do an 11/12 times a 12 over a 1. Well, I can do a 12 divided by a 12, which is really just a 1. So I just want to multiply that 11 by 1 to get an 11. So what I did was I eliminated these fractions here. But obviously I still have fractions because these numerators still had fractions in them. But we do not have to work with those fractions. Instead, what I could do is I can multiply my entire equation now by the denominator, or the common denominator of the two fractions that I have left. So the common denominator of the two fractions that I have left would be a 4. So I'm going to multiply everything, every term, by 4 over 1. When you multiply every term in an equation by the same number, you do not eliminate, or it does not change the value of your equation, it just changes how it looks. So a 4 over a 1 times a 12x is going to be a 48x minus a 4 over a 1 times a 3, or 4 times a 3 is a 12, minus, all right, when I do a 4 over a 1, times a 9x over 2, what I really can do is I can do a 4 divided by a 2. So that 4 divided by the denominator of 2. And that's a 2. And I really just multiply the numerator 9x by 2, which would give me an 18x. That will equal, continuing on, a 4 over a 1 times an 8 is a 32 minus a 4 over a 1 times a 4 over a 4. So what I can really do is I can do a 4 divided by a 4, which is a 1. And now I just multiply that numerator 4x times that 1, so I get a 4x. And then a 4 over a 1 times a minus 11 is going to be a minus 44. So now all my fractions are eliminated, which makes this equation much, much easier. So now I can combine like terms on both sides. I have a 48x minus an 18x to get a 30x minus a 12 is equal to, on the other side, I have a 32 minus a 44, which is a negative 12, and then minus a 4x. Getting my variable on one side, I'm going to add 4x over. So I have a 34x minus a 12 is equal to a negative 12. And then I'm going to add 12 to both sides to get a 34x is equal to a negative 12 plus a 12 is just a 0. And then I can divide by 34 on both sides to get just x is equal to 0. And that's it. Now there are many different ways to do this problem. I just showed you one way. And that one way that I showed you, I worked on eliminating my fractions to get an equation that looks like something we've dealt before. All right, that brings us to the end of this lesson.